Okay, we have to start by showing that n squared plus 3n plus 2 is even for all possible n's. So I need to show that 2 divides into n squared plus 3n plus 2. Can I factorize this? N plus 1. Yes, n plus 2. So we're done, because either the first one, either this is even or this one is, because they're neighbors, because n plus 2 is the next natural number after n plus 1. So one of them has to be even because they're neighbors. So either the first one is or the second one is. They both can't be even, they both can't be odd. One of them has to be even and one of them has to be odd. So that's the first one done. Okay. Prove that this is divisible by 6 by induction. Okay, so we'll start off with case n equals 0. So this is 6 divided into 0. That's true. Now we assume is true for n equals k, i.e. 6 does divide into k plus 1, k plus 2. And now number 3, step 3, we're required to prove case n equals k plus 1. So that is that 6 divides into k plus 1 times k plus 2 times k plus 3. So it seems like we're actually not too far away. We have a k plus 1 and a k plus 2. So if I split the last one, I need to show that 6 divides into k plus 1, k plus 2 times k plus k plus 1, k plus 2 times 3. So k plus 1 and k plus 2. So this one's true from just step 2. So now all that's left to prove is that 6 divides into k plus 1 times k plus 2 times 3. I see where this is going. So that means we need to prove that 2 times 3 divides into k plus 1 times k plus 2 times 3. Well, we know the 3's will cancel. So all that's left to do is to show that 2 divides into k plus 1 times k plus 2, which is true from part 1 of this question. So step 4, 1 plus 2 plus 3 means it's true for n equals 1, n equals 0, 1, 2, 3, etc.